In this video, we're going to look at section 2.9, subtracting integers. So first, notice we talk about the language of subtraction. So there's a few different ways we speak of subtraction: minus language, subtraction from, less than, and decreased by. And since subtraction isn't commutative, and these sometimes reverse the order of the words, we really need students to be aware of this, so when we're talking about subtraction, they understand. Also, since they typically think of subtraction as resulting in a positive number, they tend to rearrange them in whatever way makes the answer positive. So in minus language, this is 5 minus 3. This is 3 subtracted from 5. This is 3 less than 5. And this is 5 decreased by 3. Also notice with the less than language, you'll see there's a Math AS question on this. So it's 3 less than 5. And some students will confuse this with the inequality notation. 3 is less than 5. And for this question, they'll put something like this. So you might want to talk a little bit about, if this comes up, or maybe even if it doesn't, about the word is and how this is usually representing a relationship between two or more quantities, such as an equation, 4 is 2 less than 7, whereas this, just the strictly less than, is referring to the subtraction. Okay. And then we're going to start in on subtracting integers with chips. So we have 5 different problems for subtracting integers with chips, and I used takeaway for 2 of them, comparison for the other 3, but I'm going to start with just doing all of them as takeaway. So we have 5 minus 3, negative 5 minus negative 3. Just going to erase that. 3 minus 5. And 5 minus negative 3, and negative 5 minus 3. Okay, so again, the order is intentional. These two are grouped together. And now again, we're thinking of starting with the first number. So you represent the first number, and then you want to take away the second number. So I'm going to circle 3 positive chips, and we're left with 2 positive chips. Here we have 5 negative chips. We want to take away 3 negative chips. And we're left with 2 negative chips. Again, so notice the symmetry. Here, notice they're both positive again, but this result is negative, which is why we have an additional type of problem in subtraction. We have 3 positive chips. We want to take away 5 positive chips, but we're going to need to add some pairs. So I want 2 more positive chips to take away, but then I need to put in 2 more negative chips to compensate for the 2 positive chips. So notice this is still equivalent to 3. Now I'm going to take away the 5 positive chips, and I am left with negative 2. Here we start with 5 positive chips. I want to take away 3 negative chips that I do not have. So I need to add 3 plus or minus pairs. Take away the 3 negative chips, and I'm left with 8 positive chips. One thing to note, when you start adding the positive negative pairs, you've probably seen them students do this in other parts of mathematics. They tend to write them and then they simplify them and cancel them all out, forgetting the purpose of why they're adding the chips to begin with, and get back to where they started. Okay, so they start thinking of combining again as opposed to this takeaway method. So you want to remind them they're taking away. And now we have 5 negative chips. We want to take away 3 positive chips. Also here, they might forget that this is a positive 3 that we're taking away. They start to see negative 3 instead of subtracting positive 3. It's helpful to use the language negative 5 minus positive 3 to help them with that. and we want 3 to take away, and then we need to balance it out. Take away our 3, and we're left with -8. So I do this in more detail in the student videos if you want to see that again, or in more detail, but that's the gist. Okay. Notice in the videos I use the comparison method for these 3, just to practice the comparison method. I think it's probably good to do all of them as takeaway and then maybe do some comparison. So let's see how we do these with the comparison method. So with 3 minus 5, we'll just do 1 or 2 of these. So the idea is, with comparison, what would I add to 5 to get 3? Okay. So you're starting with 5, and you want it to look like this. So now in another color, well, I would combine 5 with 2 negatives to make it look like this. So the result is -2. So so now we're back to addition. Combining 5 with 2 negatives gives us +3. Or the next one, 5 minus -3. Okay, so you're saying, what do I add to -3 to make it equal or look like 5? So we're starting with -3, and we want it to look like +5. So in a different color, I'd write what I need to add to this so it equals this. Well, I'd need 3 positive chips just to get to 0, and then 1, 2, 3, 4, 5 more positive chips that would equal 5. So our result is 8. Okay, so they're both useful. Whichever one your students connect with more, or you can try one or the other or both. Okay. Here we have connecting addition and subtraction, and this section is notoriously difficult for them. We want them to rewrite the subtraction problems as equivalent addition problems, especially with ones like the first one, 4 minus 7. When you ask them to rewrite it as addition, they write 4 plus 7. Okay, so they need to understand the equivalent part as you're going through addition and subtraction. We used to have a video in here, but we shortened this section. You can show them why our general result, that subtracting an integer from a number, is the same as adding the integer's opposite to the number. And it's really evident in the chips. So basically the gist of this is we have 4 minus 7 is 4 plus -7. Okay, and then you'll have them do this using addition. So starting at 0, 4, and if we want to combine -7, that takes us back 0, and then another 3. Okay, and then you can even show them with the number line how that's the same as 4, and then subtracting 7 would be 7 to the left. Try to avoid the chop thing. They love the chop thing, and they'll chop anything you give them. Okay, but we want them to know that 6 minus -2 is equivalent to, instead of chop, instead of subtraction, we're adding. Instead of subtracting a -2, we're adding a +2. Also, the chop, this looks confusing because suddenly now this is a positive, even though we barely ever write positives with the symbol in any other situation. It also has them get in the habit of canceling out negatives in front of numbers, and of course this would be fine in general, except when they have this later and they chop that and they don't distribute. Okay, so we really want them to realize that it's changing the operation and changing the sign of the second number. Now, using algorithms to add and subtract integers, let's just do a quick overview. So again, these are grouped in a very intentional way. We have them with two large numbers, add them and subtract them, and then put them in all the different or most of the different combinations of, all, of adding and subtracting their signed corresponding values. Okay. So here we're adding the two negative, here one's negative positive, and then we reverse it. So beyond the goal of this exercise, or the goal of this exercise beyond just having them do this, we want them to see the connections between, if you're given two numbers, basically you're going to add or subtract those numbers and then you determine the sign. So once they've done this, okay, these problems are easy. They have to see that they're combining two negatives, so those negative chips are accumulating. Granted, we definitely don't want them writing this many negative chips, but hopefully they can visualize that, so the result is negative. Here they have positive and negative chips, more positive chips, so the result is going to be positive, and we want the difference, so we'd use this result, etc. Okay. And we'll start the next video with multiplying integers.